if you recall, we started with plate operations, plate preparation, right, then plate cutting, followed by plate and frame bending, and now the question of joining them. So welding is nothing but a technique of essentially joining. If you go back pre-World War, it used to be primarily riveted ships. Ships used to be riveted, but now, as we see, we have almost done away with riveting as a method of joining. It's all done by welding.
So what was riveting?
Riveting is, well, riveting is, it is something like this. Say if I look into the hull in the context of shipbuilding, it has to be done in this way. That means one plate is coming and it is being riveted to the other strake, right. In this fashion it will have to go. Here it is riveted. So what happens, suppose two plates are to be welded, so you have to shape the plate in this way. That means this line remains flat, one line, that is my internal surface, suppose. So when I am joining the two both the plates, so one plate is overlapped, right. You drill a hole here and put a rivet. Rivet is physically, it will look like this, right. That means basically drill a hole. The rivet originally will look somewhat like this, right. So this is put in the hole, and from the other side you hammer it and make it flat, I mean give this particular shape. So they will hold the plate together. So that is the operation. That means first you will have to bend the plate at every joints. Suppose this is the side shell plate. So you bend the plate all along the length like this, such that you can overlap. This kind of is referred to as lap joint, right.
So, but this joint is not waterproof.
No, it can be made waterproof. That means that is the design of the joint. So how many rivets at what spacing, how compressed they are, all those are the factors. So thereby it will be made watertight. There is no problem. But you think of the involvement in the entire process, how much of work involved. You have to shape the plate that way. That means there is additional work. You have to drill hole in both the plates in unison, so that they match, then insert the rivet physically and then do hammering. So this is the process of joining. And now when you do welding, then it becomes much more simpler. This is riveting, right. And when you do welding, then you have the plate like this, and the another plate you just put just face to face as if, and weld it, right. So no additional work, only the work of welding, sort of you align them and weld it. Anyway, so this is no more done, this riveting. Now all jobs are through welding. Now when we talk about welding, what welding is, essentially welding is nothing but a method of joining two pieces of metallic plates. It can be non-metallic also, but here we will talk about metallic plates only, steel, aluminum welding, right. So the entire process involves how these two plates become, means two pieces of plates put together by means of welding, it makes it one integral plate, right. That means the entire continuity is established between the two plates along the welded joint, along the welded line, right. So how that can be done? That can be done by various processes. One of the process could be you make the surface so smooth and bring them so close that a metallic bond is formed, a molecular bond is formed, and the plates get joined. That can be referred to as solid state welding, right. But that is not very feasible in case of shipbuilding, right. So what would be the other method? Other method would be through friction, generate enough heat and make the surface smooth enough so that they come together close enough to form that molecular bond. So, that can be referred to as a friction welding, right. There can be another process that pass a current through this, through the joint, right, such that the interface generates sufficient heat to melt locally and then withdraw the current, so it solidifies. That means by melting, by fusion. So, through fusion, what is being done, that the metal is brought under a liquid state wherein the molecules are free to move around. So, once the heat is removed, they solidify and becomes one. The necessary metallic bond is formed. So, that is what is fusion welding. So, here we will talk about fusion welding. While doing fusion welding, we need to have, that means, external source of energy, which will in the form of some heat or whatever, which will melt the plate, means raise the temperature of the plate to the melting temperature. So, one of the process would be using electric arc. That is how that particular welding process can be referred to as electric arc welding, right, electric arc welding. Other method of fusion welding could be, well, as I said, resistance welding. That means resistance is electrical resistance. Through that, it generates enough heat and the fusion takes place and the welding. There are other methods also. Well, maybe those methods we will talk about later. Now, concentrate on these, that electric arc welding is the primary what you call the fusion welding process, which is most commonly used. That means here the heat source, here in this case the heat is obtained through the electric arc, to melt the plate. Heat is obtained from the electric arc, right. There are other methods of fusion welding, like even you can think of using a so called beam, laser beam, to melt the plate and do the fusion welding. So, that will be termed as laser welding. You use the resistance of slag, molten slag. Slag is nothing but which you get by burning the flux, that gives protection to the molten metal. So, resistance of the molten slag can be used, which we refer to as electroslag welding, right. That is also a fusion welding. The heat is coming from that slag, electroslag welding. I can use the solar energy, concentrate it, melt the plate and do the welding, solar welding. I can use electron beam, right, focus it to the point and that will generate intense heat. I can do the welding, electron beam welding. So, these are all exquisite type of welding processes. We will not go in those, we will go up to the electroslag welding, right, and some more. We will talk about that later. So, under the heading of electric arc welding, we will have again certain different types of welding processes that we will see later. Now, let us see that where from we are getting the heat, from the electrical power. That means there is a something called power source, right. When we have a electrical power source, we call it electric arc welding. When the power source is a laser beam, laser welding, right, like that. So, all those welding, electric arc welding, resistance welding, electroslag welding, submerged arc welding, gas metal arc welding, all those are basically electric welding. In some cases, we are using electric arc, in some cases, we are using the resistance of the metal interface or of the flux, I mean slag, burnt flux. So, anyway, in all these cases, we use a electrical power source, right. So, we look into what are the types of power source. First, let us look into the types of power source. So, what we do that generally welding power source are low voltage high current power source. Generally welding power sources are low voltage high current. That means the power which we will get will be able to deliver very high current. For example, our domestic power source, what is the domestic power source? Voltage is 220 volts approximately, right? 220 volts, and it can deliver to a maximum of probably the wiring you have nothing more than 15 amperes. Nothing more than 15 amperes. That is why you will see generally the highest amperage socket you have is of that of 15 ampere. Means definitely you are drawing current less than that. That means which all equipment draw more current? Like geyser, iron, air conditioner, they draw quite a heavy current when you switch on. Then it falls down a little bit, but still current. So, maximum is around 15 ampere, right? And voltage 220 volts. So, if accidentally if you touch the terminals and you get a really a severe shock, right, and that shock period if it extends, one can collapse straight, fatal, it can be fatal. Whereas in welding power source is just the reverse. The voltage level would be of the order of, well, the open circuit voltage will be of the order of maximum, say around 80 volts, 80 to 100 volts maximum. Open circuit means when you are not doing any welding, you just put a multimeter, put a voltmeter across the terminal, it will show 80 or 100 maximum. That is the open circuit voltage, and current could be, depending on the capacity of your machine, it could be 100 ampere, 200 ampere, 300 ampere or 3000 ampere of that order, right. That means welding can be that means even in the low power welding, right, there also your amperage will be of the order of 100, whereas we saw in domestic power it is only 15. Voltage is 80, whereas the ampere is 100. Little high heat or high heat input welding or whatever more more powerful welding, if I say, could be of the ampere of 600, 700, 800 ampere. It can go up to even 2000, 3000 ampere, right. So, that is how it is basically a low voltage high current power source.
So, what is the advantage of having this?
We will come to that. It is low voltage high current. Okay, maybe we can see. So, how the heat is generated? If we just look into the it is the entire circuitry is very simple. This is your power source, right. So, what you have one terminal connected to the electrode and another terminal connected to the job. Generally, this is the configuration, right. This is my electrode and this is the job. So, this is the workpiece or the job or the plate which is being welded, right. This is my power source. So, power source could be either direct current power source or could be alternate current. That means, it could be either DC or AC, right. Well, if it is DC, then either of them will be plus or minus. That also has a significance. We will see that later. If it is AC, well, then one is live, other is neutral, right. So, this is the circuit. So, if I look into the electrical circuit, probably it would be something like this. Let us assume a DC power source. So, we have like this, positive negative terminal, there is one resistance, this is my So, R and RA, that is all. R is the resistance in the entire circuitry, that means the internal impedance of the machine, and that of the resistance of the cables, and RA is the arc resistance in the arc, the resistance here, arc resistance, right. So, if the voltage is V, then I have a current I flowing in the circuit, then my heat generated would be what? Would be I square R A. Heat generated would be I square R A. There is a joule heating taking place, right. That is how the current is important. That is how we have high current, because had it been current of the order of 10 or 15 ampere, then hardly any heat would have been there. So, we talk about 100, 800, 1000 ampere. So that I can have a high current, because RA is the resistance of the arc column that I cannot go on increasing. The resistance of the arc column is very low. It is essentially the resistance of the plasma column, ionized gas, right. So, that is somewhat fixed, because you will have a somewhat size of the arc column. You cannot make it very big, the instability of the arc will come. You cannot make it very short, there can be chances of short circuit. So, it will be sufficiently small. I mean, that will not contribute much. What contributes is the current. So, welding current, thereby we see that becomes one of the very important process parameter in the entire thing. That is how the welding current, it will depend, it is a square of the current. So, it will, how much heat is generated will depend on the amount of the current. So, that automatically tells us that if we need to weld a thicker steel plate, I need to have a higher current, because I want to melt more metal, more heat is needed. I want to increase my welding speed, or I want to increase my deposition rate, how much metal is being deposited. Again, will depend on then welding current, because more the current, more heat is generated. So, more metal can be melted. So, welding current becomes one of the very important process variable, one of the very important welding parameter. We will see its effects later. So, that is how the current is important. Now, we have been talking about this power source. This power source. What is this power source? It can be either DC or it can be AC. Now, we will see that if it is a DC power source, right, then this voltage or current would be something like this, straight with time, right. If it is a AC one, then obviously it will have a cyclic thing, and obviously we will be using the so called line power. Line power means the power being generated, the common what do you call industrial power, which is being generated in the power plants. So, that power we will use. Obviously, one can use where this so called line or supplied power is not available, you will have to have your own generator or own alternator to generate power. That is a different issue. Again, the same thing, if I use the alternator, I generate AC power. If I have a DC generator, I generate DC power. So, either I use a DC generator and directly use, or I use the alternator, use a rectifier and make it DC if I want. If the line power I use a transformer, and if I want to do AC welding, I do AC. I use a rectifier to get it to DC. So, either of these two are used, right. Obviously, now which one to be used? Naturally, the one which will give me a consistent quality, a good quality at the end of the job. I mean, the job should have a superior quality, rather I will say. A job which will, where I can control the parameters more finely, such that I get the desired joint quality. Desired joint quality means the welding, the purpose of welding is not barely to join two plates, but to make them integrally one, means as if it was only one, there is no two separate plates. That means the joint should have the same physical and mechanical parameters, if not superior, compared to those of the original parameters, original properties of the plates. That means the welded joint should be free from all kinds of defects, right? Should have and also should produce a microstructure and the mechanical properties that of the original plate. That means have good properties. So, to achieve that, what do you think from common sense, which kind of power would give you better result, DC or AC? Just to start with, generally DC, direct current, for the simple reason, you see what happens with AC. As I see, with time it increases, decreases, then at a one point of time it goes off. It is zero here. The power is zero, voltage or current, whatever in the circuit is zero. Again it is picking up, going to maximum, decreasing, again becoming zero. So, or in other words, the electric arc gets extinguished how many times? If it is a 50 cycle power, 50 times or 100 times? I think so, 100 times per second. So, per second 100 times it is going on and off. So, it is happening very fast, so we do not see, right. And also the heat, this I square RA is changing continuously. It is becoming maximum, coming down, becoming zero, again becoming maximum. So, it is a kind of a fluctuating power. If it is a fluctuating power, then the melting rate also will be fluctuating. So, it will lead to a fluctuation in the weld deposition. That means, though it is happening very fast, 100 times, I mean 1/100th of a second things are happening, changing. So, effect is not that that grossly visible, but the effect is there. Whereas, in this case I have a very consistent power supply, consistent heat in DC, right. So, the melting rate, the rate of melting, rate of heat generation, rate of melting, everything is uniform over time. So, I get a very consistency in deposition in DC. So, obviously, if I use DC, I expect to get a superior quality of weld deposit. The weld deposit, what is important, that how I am depositing the molten metal from the filler metal, the electrode being melted and getting deposited, and thereby also the parent metal is melting, both are getting mixed up and getting solidified, welding is being done. So, weld deposit is also important. So, the quality of the weld deposit will depend on the power supply. So, a DC power supply will give you a better weld deposit. There are other aspects. So, so in general one can say that for steel welding, when you weld steel material for shipbuilding purpose, we will use DC power supply. But if you look in the roadside welding shops, you will find people are using AC power supply and also welding steel. So, I am not saying that you cannot weld steel with AC, you can. But if you want a better quality, if you want a superior strength, you should go for DC. Now, when you talk about the roadside welding, means we are welding things which are of not that great quality requirement. So, you are welding some those grills, window grills or fencing or garden gate and all that. So, there you do not have so stringent requirement. But when you are welding for an offshore platform or a ship or a submarine, you have a much more stringent requirement. So, there we will be using DC as per when you do weld for steel. Just for information, if you have to weld aluminum alloys, that logic is supersedes some other logic. So, thereby AC becomes a preferable power source for aluminum welding. there is some other requirement, some other things happen. So, for aluminum welding AC power is used. That means, well, we have all these difficulties in the power, but that helps for some other, we will see that later if time permits. But for your information, steel is always DC for that simple reason, aluminum is AC power. Okay. Well, so we have DC power source. Now, DC power source means what? That means we have a device which can deliver DC power. Where from this DC power is coming? Well, here I have the AC line supply, 440 volt supply, the industrial power, right? 440 volt, suppose this is my 440 volt supply, 440 volt 3-phase supply. So, there will not be only 2 wire, but there will be 4 wires, 440 volt 3-phase we are putting in this machine, right, and we are getting positive negative 2 terminals DC. Here it will be, well, say open circuit voltage OCV of 80 volts about, and current it can go up to, so it can go up to say 1200 ampere. There is a capacity of the machine. That means it can deliver up to 1200 ampere. So, what is this machine then? This is a rectifier, essentially a rectifier, right? No, just a rectifier, right? Well, transformer means internally you have a current transformer sort of, right, wherein you bring down the voltage but boost up the current, right, and then rectify it, right, and you have a DC output, right. So, now if I measure the output here, then we get the open circuit voltage. If I measure the power in the arc here, in the arc, then I get arc voltage and arc current. Okay, arc current is nothing but the current in the circuit, but the arc voltage is the voltage drop in the arc. So, more important parameters are essentially arc voltage and arc current, not OCV, not the open circuit voltage. How much drop is there in the arc, that is important, because that is generating your heat, because V, that means essentially if arc voltage is VA and the arc current is I, arc current is nothing but the welding current in the circuit, right. So, your heat is once again is I into VA, voltage drop at the arc, right. Okay. So, if we measure this voltage and current output at the arc, then we get a certain characteristics, certain distribution of that, right. Depending on those characteristics, we have, well, there the output voltage versus output current. If we plot, output means here I mean the voltage in the arc and the voltage and the current in the circuit. This is referred to as volt ampere characteristics, right. They are basically static characteristics, they are easily measurable, because I put a shunt there in the arc, I can measure what is the voltage drop, and then the circuit I put ammeter, I get the current, like we do welding in our lab, we can measure it very easily with simple devices. So, that is what is the static characteristics. Another thing is referred to as dynamic characteristics. What is that? They are transient variations in the output voltage and current. this relation of output voltage and output current is somewhat fixed for a given machine, for a given power source, right, somewhat fixed for a given power source. If I refer to this R I have written is a welding power source. Welding power source, it will have a static characteristics as well as dynamic characteristics. Static characteristics is the relation between the output voltage and the output current, how it is behaving, right? And the dynamic characteristics are the transient variations in this output and current and voltage. Those transient variations are very highly transient. Transient means what? They are not constant. They occur for a very short period. They keep changing. So, they occur in a period in the order of 0.001 second, very short period. When these dynamic phenomena are visible, they are visible when you initiate the arc. Just start the arc. At that point, whatever the variations will take place in the current and voltage, output current and voltage will depend on the dynamic characteristics of the power supply of that machine, because here it is a combination, it is a power supply. I am giving a 3-phase power, I am getting DC power. In very many ways I can get that. So, depending on the characteristics of that, depending on the type, make, I mean how you have designed it, what all facilities you have incorporated, you will have a certain type of static characteristics, a certain type of dynamic characteristics. We will come to static characteristics a little more in detail. As far as dynamic characteristics are concerned, just few words, because they are of very transient nature and they occur only during the striking of an arc, means when you are just initiating the welding, and then it continues. So, your dynamic characteristic plays a role at the time of initiation of the arc, that is one. During rapid changes in arc length, for some reason the arc length is fluctuating, right. So, then also dynamic characteristics will play a role. During metal transfer across arc, the metal is getting transferred, that is happening continuously, because electrode tip is melting and getting transferred, right.
So, what is the direction of transfer?
Hmm?
The joint.
Which what?
The direction of this metal transfer.
Direction of metal transfer? No. Direction of metal transfer means metal getting transferred from the electrode to the job, from the electrode to the job. We will come to that little more later. So, anyway, that is how we see that dynamic characteristics are the one which does play a role, but not very, so to say, not very significant as such, because it is primarily when you are just starting the welding, then you do not have. Again, if you do not fluctuate the arc length, if that can be very well controlled, there is not much of problem. Only in metal transfer, okay, dynamic characteristics may play a role. So, that is how we see that generally the power supplies, they have certain static characteristics. They do not take care, the ordinary power supplies do not take care much about the dynamic characteristics. Only very elaborate sort of circuitry and expensive machines will have a very good dynamic characteristics. Means essentially what? Just at the time of striking the arc, what you are doing? You are short circuiting it, right. So, there will be a sharp change in the current and voltage. So, to take care of that sharp change in a very short time, that will be in a much fraction of a second. So, the machine should be capable of withstanding all those fluctuations, right. So, that is how dynamic, in fact, if a machine has a good dynamic, a machine power supply with a good dynamic characteristics will give us, well, improvement in the uniformity of metal transfer. that means we will be able to achieve even higher quality of metal deposition, right. Your reduced weld pool turbulence means when the when you are doing the welding, the electrode will be just facing the metal below, will be in a molten state. It will be a molten pool of metal just below the arc. Naturally, the heat, you will continuously have a molten pool of metal which will keep moving along with the arc moving. So, that molten pool of metal, there will be heavy turbulence in that thing, turbulence because of your metal droplets are falling. So, that will cause turbulence, that will cause spatter. Suppose you drop something on liquid, it splashes, that is called spatter, right. That is called spatter. So, lot of spatter is bad, because lot of metal is wasted, and that may give rise to certain defects also. That means, if along the weld line you have lot of spatter, that indicate that you may have a bad welding done. I mean, defects are there, could be, because when the metal spatter, why? Because lot of turbulence occurred and metal got spattered. So, there can be an entrapment of gas, some porosity may have formed. Anyway, so this, since the transient variations are less, so spattering also would be less. You will have a uniformity metal transfer, but all these are essentially when you have that transient variation, striking of the arc, extinguishing of the arc, means at the beginning, at the end, they mainly work. So, transient variation or the dynamic characteristics are not that greatly important. More important is, or more role is played by the static characteristics. So, depending on the static characteristics, we have generally two types of power supplies, right. One is referred to as constant current, and another is referred to as constant potential or constant voltage. So, this is referred to as CC, this is referred to as CP or CV, constant potential or constant voltage. These are based on the characteristics, the voltage current output, by plotting the relation between the voltage current, this output voltage versus output current, right. So, what is this? So, in one case we call it constant current, in another case we call it constant voltage. So, if it is a constant current, then we have a power characteristics something like this. This is your current, this is your voltage. So, this is referred to as a constant current characteristics. Or a CC power supply, constant current power supply, or a power supply, DC power supply having a constant current characteristics. Now, tell me why we are referring to as constant current. I can see the current is, well, changing, not only changing, it is drooping, right. So, also at times people call it a drooping power source. I mean, if somebody tells you drooping power source, you should not be surprised. That means he is referring to a constant current power source, or he is referring to a welding power source which has constant current characteristics, because power sources can be, in one power source you can have all these characteristics, only thing you have to change the settings. you change the setting to a drooping characteristics, you change the setting to a flat characteristics. The other one is referred to as constant voltage.
So why is this called constant current?
Yes, will come, just let us draw this CV or CP, and also referred to as flat. Why flat? Here we see somewhat like this. Right. Well, constant current means, because what is happening, we are checking into the voltage current characteristics. Voltage current characteristics means when I am doing the welding, then I have a certain arc voltage and a certain arc current. Certain, instead of arc current, generally is referred to as welding current. Certain arc voltage and welding current, or whatever, voltage and current at the arc, right. So, at that voltage, what is happening to that current, or the total power we are interested in, I into VA, that we are interested in. So, what you see here, for a given voltage of the, for a given arc voltage, this is my arc current in the arc, right. Now, what is liable to change here in the process? Liable to change is the electrode position. Suppose I am doing a manual welding. So, what will happen? The weld electrode is getting consumed. So, when I do a manual welding, the movement of hand is somewhat like this, right. It will, it has a translatory motion in this direction as well as in the Z direction. You will have to gradually come down. So, how you are coming down, how much your hand is shaking and all that, that will affect the arc length. Arc length will change, keep changing. If the arc length changes, then the voltage drop at the arc length, arc will change. That means VA will keep fluctuating, right. VA will keep fluctuating, because small minute changes in the arc length will have a significant effect on VA, because the current is very high. Current is say 150 ampere. When you are doing manual welding, current will be of that order, it can be of that order, 150, 200 ampere, 250 ampere, right. So, from here to, suppose the voltage changes up to this much is my fluctuation of the voltage. From here it drops to this much, or from there it increases this much. So, my current changes is only this much, right. Now, if I have a another power supply, constant current power supply, wherein I have the circuitry such, or other whatever it gives this particular characteristics, I make it such that I have a more stiffer curve. This nature of the curve is more stiff. That means, this is my machine A, power source A, and this is my power source B. Both are having, suppose you go to the market and you want to buy a constant current power source, and fellow in the shop, he shows you two machines of same capacity, both means it can deliver. Primarily, you will look for how much ampere it can deliver. So, you see both are giving you 1200 ampere, but he is saying the machine B is much more expensive than machine A, but both are of same capacity. Why expensive? Its volt ampere characteristics are different, it is better. Why? Because here you see, for the same change in voltage, your change in current is hardly anything, very small, right. That means, it is approaching to the true constant current condition. That means, though my hand is not very steady in welding, my hand is shaking and the welding arc is changing, but the metal deposition is constant. because heat generated is more or less constant. VA is changing, that changes more from 20 volt to probably 22 volts, 25 volts, but current change is hardly anything, right. That is why it is referred to as constant current. That means with fluctuation in the arc voltage, the change in current is less, much less. That is what is a constant current characteristic. So, a machine power supply with a characteristics similar to that of B here is more preferable. And obviously, it shows that when I do a manual welding, it is preferable to use a constant current power source. If I do manual welding using DC power supply, preferable to use a constant current power source, because then the weld quality will be better, because even if there is a fluctuation in the because of the welder's fluctuation in the arc, your metal deposition will remain fairly constant. What happens in the constant voltage? Here we see, what you see here, that there is a, that means in constant current some change in voltage causes very little change in current. And here a small change in voltage causes very high change in current, just the opposite. Constant voltage power supply is just the sort of opposite to that of constant current. There is a certain change in the voltage you had a very small change in current. Here the same change in voltage, you have a very large change in current, right. The nature of the constant current curve is drooping down, that is why it is referred to as drooping power source. Here the nature is somewhat flat, horizontal, so it is called flat power source, but I have drawn a curve which eventually goes and meets the current axis. That means there is a negative slope. Why this negative slope? Ideally it should have been horizontal, internal impedance, resistance, but we better talk it impedance, because it is a combination of LC, RLC circuit, right. So, because of the internal impedance, there will be a downward slope, a negative slope, and you have here this particular phenomena that for a small change in voltage, you have a very high change in the current. So, what does it give? What do I use this? Well, in this, what I see then, that for in this, so for some reason, if the arc length changes, right, so immediately there will be a very surge of very high level, high amount of current. If the arc level increases little bit, or sorry, here it will be actually decreases, decreases for some reason, immediately there will be a surge of current. So, what will happen? Spontaneously, instantaneously, there will be a lot of heat generated, and it will the arc length will come back to the original length. Hence, it was here, the arc length was here sort of, which corresponds to this voltage. For some reason, the arc length has dropped. If I further go on putting it down, then it may stub in the weld pool, and the welding will stop, right. That means short circuit case will occur instead. So, what happens? Suppose it comes down to this level, immediately there will be a surge of current. So, what will happen? It will burn off that tip of the electrode and restore the required arc length. So, it works a kind of a self regulation. It gives a kind of a self regulation of the welding arc, self regulation of the welding arc, right. this constant voltage power supply. So, this is useful in case of automated welding, when I have a constant feeding rate of the electrode. One can design a welding machine where I can continuously feed the electrode. In manual welding, I have a welding stick, right. I weld it, it is over, I throw the butt and put a new stick, again I weld. If I have a coil of welding wire and I have a mechanism of continuously feeding it, I can continuously weld. So, in such, if there is a mechanism wherein I can feed the filler metal, the welding electrode acts as the filler metal that melts and gets deposited. So, there it will be worthwhile to use a constant voltage power source, because feeding rate is constant, and if there is any undulation in the plate, or somehow the electrode is coming closer to the plate for some reason, little undulations. So, basically the welding arc will become smaller, immediately there will be current, high surge of current, it will change to automatically the required arc voltage. So, that is how constant voltage for automatic operation, constant current for manual operation. But again, there is a thing, if a very skilled welder is there, right, and who is doing some repair welding, in case of primarily repair welding means some crack, some fracture, some damage has taken place. So, you have cut it out, and that portion you are depositing metal to fill it up. So, at some place you need certain deposition, some other place you need a more deposition, and so on and so forth. The amount of deposition is varying. So, then what happens, as I have told, since deposition rate will depend on the current, right. So, if you are doing manually, and a repair welding will always be manually, generally we will not put any automation in repair welding, it will be manually done with a manual stick electrode, which is referred to as MMAW, manual metal arc welding, the general abbreviation, manual metal arc welding. So, there what one can do is, one will have to change the current continuously, right. So, that is difficult. Instead, one can use a constant potential power supply, a skilled welder, and he plays with the arc length. He wants more deposition, he increases the arc length, he pulls up the electrode. Those are in fraction of millimeters, very highly skilled. Little bit he extends, he gets much high current, more deposition. So, very skilled welder, one can use this for specific cases. Anyway, we stop here today. Tomorrow we will see metal transfer mechanism and welding parameter and their effects.